What's up, random strangers? Today I'll teach you how to create a cup mixer in Unity 2022. I'm not really interested in making videos anymore and haven't been interested in a long time, but recently when working on a game I found out this very simple thing didn't have a proper tutorial on YouTube. The only tutorial I did find was just moving the die around, and if you move the die without moving the cups, there's no way to follow it. So I had to come up with something from scratch. It wasn't that hard, but I still figured there should be some YouTube tutorial about it, so here we are. Alright, so as you can see, we've got the basic scene set up. There isn't much here since this is a really basic tutorial. There's a canvas, there's a camera, a background, which is of course optional, the counter to see how many times in a row you got this, and of course an empty game object to hold all the cups, which are buttons, so they could have an on-click event, and the correct cup is the one with a child, that is this die image. So this is the scene. Now that we've got the scene, let's create a new C# script and start working. Alright, so as you can see, we've got ourselves a basic script just set up. Obviously it's empty right now. So the first thing I'm gonna do is create a new public static class. We'll call it useful, because why not? I like to do it with all my projects, because this way I have a class that has, as you can tell, many useful functions in it. And also, because the class is static, that means you can do things like, for example, if we do public static button, and let's go, to use buttons we also need to call unity2d. We can even call the function button as well, and say this function receives a game object G, and it returns g.get component button. So for those of you who haven't seen this notation, basically when you've got a method in C# that is only one line, you can just use that, and that replaces the curly brackets. Now, the reason I like to do it with static classes and static methods is because you can add the this keyword, and this way, if we, for example, now have here, if we have here a game object G, new game object, just to test it out, we can do g.button right now. So it doesn't really matter, because like button G is actually useful dot button G would work the same way. I just like it as a shortcut, and I think it looks better. So we've got that. We'll use that later to get direct access to the button components in the caps, and that would be in order to set them not interactable when the shuffling happens, so you can just follow one with your mouth. I mean, you can follow it with your mouth, but it wouldn't be apparent which one you should be following. While we're here in the useful class, I'll go ahead and write all the lines for the useful class. You can follow if you want. You can stop the video, make it slower. I'll also add a Git repository in the description, so you can just copy this entire script if you want, and this way the video can go on and I can just code it peacefully, and we'll get back to it once I actually have this entire class. Alright, so now that we've got the proper useful class, let's start declaring variable for the normal behavior class, and then we'll start working from that. So first, we need to declare an int. It doesn't have to be public, it can just be int count, and let's start it at 0. And this one does have to be public. It's a text mesh protext counter text, let's call it. We also need a public game object array caps public image. Let's hold those lowercase d. We need a float, which this float will just tell us how much the caps go up. They supposedly go up, but it's actually the wiggle effect. Alright, so editor me here to explain what the dumbass me couldn't explain in the original recording. So what I meant about this variable is that, for example, this is a cap. I know it's a square, but roll with it. This would be the mixer up. And essentially what we do is all the caps go up, then they wait a little bit, and then they each go to their new position. But because we don't wait long enough, and this variable is very small, what ends up happening is they just wiggle a little bit and then they swap around. So that's what this variable does. And a bool finished revealing. Alright, so for the start function, what we need to do is count equals 0, because in Unity default values like these mean nothing, since you can change them in the inspector, even though this one isn't public, but you know. Counter text dot text is counter 0. Let's also set die.enable to false, so when you start the scene you don't really see it, although we will change that, but that's just good to be there in case you like want a dialogue or something before you start shuffling the caps. It's good to have the die disabled for now, the image. And we need to start coroutine cup mixer, which will create right now. We don't really need the update method even, so let's just start public enumerator cup mixer, and we'll get a float. We'll call it WFS for wait for seconds, and let's just set it for 0.3 for now. The first thing we want to do is declare a vector3 array, new vector3 array. There's a space there, and give it a length of caps.length. Okay, then for int I equals 0, I also caps.length I plus plus. We'll copy this vector3. Now we haven't written a copy function for only a single vector, so we'll do that right now. We're just taking that. We don't even need to take that actually, we'll just do public static vector3 this vector3 the new vector3 v.x, v.y, v.z. Of course, the reason we're building these copy functions is to avoid pointers. I could get into pointers right now, but I really don't want to explain them in a tutorial about something that basic. And so if you want, you're welcome to look it up online. Alright, so now we've got a copy here. Wait, what? No, I did it. Alright. This is supposed to be caps caps I transform dot position dot copy. For starters, for each game object say in caps, we need to reveal the caps. We'll do it later, but basically before every round, before we start mixing the caps, this is where we do it. Then the actual mixing starts. So for int I equals 0, I is less than, let's create, I just used 3, but let's create a variable for that, but why not? Public int rounds, that's how many rounds we mix. So let's set it equal to 3 by default. If it's less than rounds, I++. Then here we do vector3 randoms equals ts.randomize, which is the function in useful that randomizes the array, obviously, and then we copy that again to avoid pointer issues. And then again for each game object C in caps, we start coroutine c.translate over time. Not translate over time is just a coroutine I use. Usually for movement I use a rigid body, but translate makes the movement like you can slide to that vector per se, and that translate over time is so that you can slide smoothly and in a speed you like. So here let's put 80 milliseconds, and the movement would be vector3 dot up times mixer up. So as I said, in this stage we kind of lift the caps up before we mix them together. This was initially just for visual effects, so like you see everything and it doesn't move around, but it ended up just creating a little jiggle effect, which I like better actually, so I decided to keep it as is. Of course, once we start shuffling, we also need to make sure that it needs to be here. We need to make sure that the button c dot button, wait, what the fuck is it? C dot button dot interactable is false, because we don't want to make it too easy for the user to just follow a cup. So you just keep his mouse on the cap and it will be faded out because of how selected objects work in Unity. So now that we've got that, we'll wait a little bit. You wait for seconds. WFS, that will wait for the mix. Like, we'll mix a little bit and then it will wait, and after that let's switch them up. So for int k equals 0, k is less than ts.length k plus plus. We start coroutine caps k dot translate over time, and here is the second variation, the one with the target first. So our target is obviously randoms k dot, wait, no, it's vector v. So is random k, and we'll again make it 80 milliseconds. And now we yield return another wait for seconds, so we can, let's change them all to wait for seconds real time, so it will actually be these seconds. So now we've got the normal mixer function, and of course at the end we need to remember for each game object c in caps c dot button dot interactable equals true, because we do want them to be able to click the buttons. So now let's create this reveal function. For that we'll need two more things. We'll need two sprites. The first one will be the cap standing, as in hiding the die, and the second one will be laying down, as in revealing the die. So now we'll do public enumerator. We'll call it reveal cap, and this will take in a game object which will be the cap. So we've got a bool for whether or not we finish revealing. This bool is usually for, like, if you have multiple methods that are working at the same time, you could do like while finish revealing is false, you wait and then you continue later. Again, this is something you don't really need for this specific tutorial, but it's there because I imported it from a game that did need that. Alright, now we set the cap active, obviously, we want to see it. Now cap dot get component image dot sprite should be laying, because obviously to reveal it has to be laying first. And let's create another bool here. No, actually we don't need a bool here, we can just do it anyway. Die dot enable what is it with me today? Equals true. So this will mean that the die is enabled, like you can see the die, and then we'll hide it after we wait. So we'll yield return new wait for seconds real time. Did I misspell yield or something? Oh, I misspelled return. Alright, that's the thing I know. Alright. Wait for seconds real time, and let's wait 1 second. So the reveal could be enough. Did I misspell seconds as well? No, the time needs to be with a lowercase t. So again, we take this and we just flip it around. I pressed C instead of V. So this should be standing again. This should be false, and we did finish revealing. Alright, so now we've got this thing. Alright, so what you see right now is just me creating a few more functions to visualize this better. So these are functions that has to do with the counter text, like updating it, or if you press the correct cap, then you add 1 to the counter, and if you press an incorrect cap, set the counter to 0. The full repository is in the description if you want these functions, but basically all you need to know is, since all the caps are buttons, what you do is you create an on-click event that takes in a game object, which will be the game object you click. If you click the game object with a child image, that means this is the game object with the die, so it's the correct cap, so you act accordingly. And if the game object doesn't have a child with an image, then it doesn't have the die, so you press the incorrect um, cap, and then again you act accordingly. Alright, so here we are in Unity. I did a few things, so I'll show them to you before we get started. We've set up this script here. We've got the counter text, the caps, the images. This mixer up is how much up do they go when they wiggle, how many rounds each shuffle includes, the standing cap and lane cap sprites, and each cap has an on-click event, which is the clicked cap. Also, where's the OBS? Also here in the Visual Studio, something I forgot to do before we moved to Unity was add the cap reveal function here. And after the for loop, we wait for a second, so this for loop only begins after the reveal is over. No, I don't think I changed anything else. Alright, so okay, so I finally found the error. This thing right here is supposed to be just the index. We're getting a random index, not a random, and I get just a random number. So if, for example, the first random index was 1, then the choices would have been 0 or 2, and if it would have gotten 2, it would have tried to get the third element of a 2 integer list. Alright, so editor me here for another explanation. So basically the bug was the indexes list was just a list of indexes, so 0, 1, 2, for example. And then if we did index random blah blah blah, that would return, like, say the indexes first one was 1, so then we're left with 0 and 2. In this situation, we try to get the third element of a 2 element list, which is why we need to remove this part, so we only get the index, and then the only indexes are those that exist. Alright, so the second bug was this other function. I probably did something wrong in the math here in the second version, where it takes a target. It's probably something here that I didn't account for, something like that. I don't know. So what we did is just we changed it from using the other variant to just using this one, where you put the milliseconds first and then the vector 3. So we calculated the movement. The x movement is the differences between the x, and the y movement is literally the mixer up. We don't even need the, no, wait. It's just the, here we go up, this one goes down, this one creates the jiggle effect. So we start the coroutine of translate over time, and now it works because reasons. I really don't know why they did wrong in the other version, but as you can see, we play and it works. And if you watch this far to understand it or to try to write your own version of it, I hope it helps. As I said in the beginning, the only reason that I even recorded this tutorial is because I didn't find any tutorial for that when I tried to create a game that used this system. So this tutorial may not be the best, but I mean it works, and I hope you find it hopeful. Feel free to leave a comment below, although I'm really not sure that I will even see it. Um, and I'll see you probably never unless there's another topic.